Hi students, now we are going to discuss about elimination reaction. The continuous reaction of type of organic compounds, organic reactions. Continuation of organic reaction because of in last class we were discuss about types of organic reaction. Different type of organic reactions are there because of most of the organic compound follow the different type of organic reaction. Substitution reaction, addition reaction, and then elimination reaction. Then oxidation, reduction, rearrangement reaction, then combination of these all above reactions. These reactions follow the organic compounds. Now we are going to discuss about then elimination reaction because of the first three type of reaction we were discussed yesterday in our last class. Substitution reaction, in the addition reactions. Substitution, another one is addition. Different type of substitution reactions are there. Nucleophilic substitution, electrophilic substitution, then free radical substitution. Different type of addition reactions are there, like a substitution reaction, nucleophilic addition, electrophilic addition, and free radical addition. These are two type of reactions: substitution reaction and also addition reaction. We were discussing in last class. Now we are going to discuss about elimination reaction. Elimination. What is meaning of elimination? One of the byproducts are eliminated from the initial compounds known as elimination. For example, ethyl alcohol can be converted into ethene. Propyl alcohol can be converted to propene. Ethyl bromide can be converted to propene. So one of the byproducts are eliminated. The byproduct contain constituent ions can be obtained from or eliminated from adjacent carbon atom. Adjacent carbon, carbon. Adjacent carbon atom. So what is meaning of elimination? The reaction in which two substituents can be eliminated from the molecule. Here, carbon-carbon new bonds are formed. Carbon-carbon new bond formed. The carbon-carbon new bond formed between already the substitution present in adjacent carbon. In elimination process, always accompanied by change in hybridization like addition reaction. In addition reaction, sp hybridization can be converted to sp2 or sp2 hybridized carbon can be converted to sp3. In addition process, sp hybridization can be converted to sp2 hybridized carbon. sp2 hybridized carbon can be converted into or changes into sp3 hybridized carbon because of carbon-carbon double bond or carbon-carbon triple bond. Carbon-carbon triple bond can be converted to carbon-carbon double bond. Carbon-carbon double bond can be converted to carbon-carbon triple bond. Carbon-carbon triple bond, sp hybridized carbon. Carbon-carbon double bond, sp2 hybridized carbon. Carbon-carbon single bond, sp3 hybridized carbon. So, unsaturated group with multiple bond can be converted into carbon-carbon single bond of saturated known as addition process. Addition reactions. Now we are going to elimination reaction. In elimination reaction, carbon-carbon double or single bond can be converted into triple or double bond respectively. Carbon-carbon single bond. Carbon-carbon single bond can be converted to carbon-carbon double bond or carbon-carbon double bond can be converted into carbon then carbon triple bond. The process known as elimination reaction. So what is meaning of elimination? Elimination, the reaction in which two substituents are eliminated from the molecule. Here, carbon-carbon double bonds are created in between the adjacent carbon atom attached to the inner substituents. Elimination reaction always accompanied by change in hybridization. Change in hybridization. What is the hybridization of carbon-carbon single bond? sp3. What is the hybridization of carbon-carbon double bond? sp2. What is the hybridization of carbon-carbon double bond? sp2. What is the hybridization of carbon-carbon triple bond? sp. So, sp3 hybridized carbon can be converted to sp2 hybridized carbon. sp2 hybridized carbon can be converted into sp3 hybridized carbon means one of the new byproducts are eliminated. The process known as elimination process. So, elimination reaction is always accompanied by change in hybridization. For example, ethyl alcohol CH3 CH2 bond OH. Ethyl alcohol. The ethyl alcohol react with concentrated sulfuric acid H2SO4. Concentrated sulfuric acid. Concentrated sulfuric acid is a powerful dehydrating agent. Not only sulfuric acid, phosphorus pentoxide, In the potassium bisulfate is a powerful dehydrated orthophosphoric acid, powerful dehydrating agent. That's why sulfuric acid also powerful dehydrating agent. It's a removal of water molecule from the ethyl alcohol. What's the process of that? It is OH is a functional group. OH functional group. Nearest carbon alpha carbon, next carbon beta carbon. So OH group nearest carbon alpha carbon, next carbon beta carbon. So functional group directly attached with the alpha carbon, next beta carbon contain hydrogen is eliminated. So alpha carbon from the OH group, hydrogen from the beta carbon eliminated to form of ethene. CH2 bond H. It is a CH3, otherwise written as CH2 bond H bond CH2 bond OH. CH2 OH. Ethyl alcohol. Ethyl alcohol. OH oxygen carbon bond break. Both lone pair of electron move towards in between the hydrogen oxygen. That's why carbon hydrogen bond break. Both lone pair of electron move towards in between the carbon carbon. So carbon carbon new bi-bonds are created. CH2 double bond CH2. Carbon carbon new bi-bonds are created. CH2 double bond CH2. Then in the carbon oxygen bond break, both lone pair of electron move towards in between the hydrogen and the OH group. No. So plus water molecule H2O also removed by using concentrated sulfuric acid. Here concentrated sulfuric acid is a powerful dehydrating agent. Removal of water molecule from the within one molecule. This is a process known as in the intramolecular dehydration. Intramolecular dehydration. Hydration means water. Dehydration means removal of water. In the molecular means in between the molecule or within the molecule. Intra means within one molecule. So within one molecule contain a water molecule eliminated known as intramolecular dehydration. The process known as intramolecular dehydration within one molecule of ethyl alcohol can be converted into ethene. Here carbon carbon single bond. So hybridization sp3. Here carbon carbon double bonds are there. So hybridization of carbon sp2. sp3 hybridized carbon can be changed into sp2 hybridized carbon. sp3 hybridized carbon of carbon carbon single bond can be changed into sp2 hybridized carbon atom of carbon carbon double bond. In the process also elimination of water molecule. Another one. Then CH3 bond CH, then H bond CH2OH. N-propyl alcohol. N-propyl alcohol because of three carbons are there. 3 carbon means what root word? Probe. In the secondary the probe, primary suffix is N, secondary suffix al. So N-propyl alcohol, propyl alcohol, propanol. Common name propyl alcohol, IUPAC name propanol. In the compound react with the concentrated sulfuric acid, H2SO4, concentrated sulfuric acid. In the OH from the alpha carbon, hydrogen from the beta carbon. OH from the alpha carbon, hydrogen from the beta carbon. So adjacent carbon carbon atom contain OH and hydrogens are eliminated. So new carbon carbon double bond formed between and then substituent group attached to carbon carbon atoms. So CH3 single bond CH double bond CH2 plus H2O removed. H2O removed. It is a 1 propene, 1 probe, ENE, 1 propene, probe root word. Total how many carbon? 1, 2, 3 carbon. 3 carbon means root word probe root word. Next carbon carbon double bond. It is a primary suffix in. In the carbon carbon double bond present in first carbon. So that means these compounds can be IUPAC named by 1 propene. So N-propyl alcohol can be converted into 1 propene. It is also one of the elimination process. Next one, N-propyl bromide. CH3 CH2 bond H. Then CH2 bond Br. N-propyl bromide. The N-propyl bromide react with the alcoholic solution of potassium hydroxide. Alcoholic solution of potassium hydroxide. Alkyl halide react with the aqueous solution, alcoholic solution. 2 types of important chemical reactions are there. Alkyl halide react with the alcoholic solution means elimination reaction takes place. Alkyl halide react with the aqueous solution means substitution reaction takes place. In substitution reaction, new products are formed. In elimination reaction, also new products are formed. In substitution reaction, one substituent group substitute in the place of another substituent group. In elimination reaction, adjacent carbon-carbon atom container, two substituent groups are eliminated. Here, carbon-carbon double bonds are formed, known as in the elimination process. It's a functional group. Functional group nearest carbon, alpha carbon. In the next carbon, beta carbon. Then gamma carbon. Alpha carbon atom container bromine. Then beta carbon atom container hydrogen. Then HBr moved. So carbon-carbon new bonds are formed in between alpha and beta carbon. So CH3 bond CH, double bond CH2 plus HBr move. Here the carbon-carbon single bond, what hybridization? sp3 hybridization. The carbon-carbon double bond, what hybridization? sp2 hybridization. So sp3 hybridized carbon can be changed into sp2 hybridized carbon. Not only in this reaction, all elimination reaction always accompanied by change in hybridization of carbon atom. Change in hybridization of carbon atom. Another one, then CH3, one C, then CH3, one CH, then OH, one CH3. What is the name of the compounds? What is the parent chain of the compounds? 1, 2, 3, 4. 4 carbon in parent chain. So root word is probe. In the third carbon directly bonded with 2 alkyl group. That means called a prefix. 2 alkyl groups are prefix. Then primary suffix is ane because of all carbon-carbon single bonded atoms. So primary suffix ane. Secondary suffix OH group. Secondary suffix name of alcohol is all. Alcohol is all. So 3, 3 dimethyl. 3, 3 dimethyl. 3, 3 dimethyl. 2 butanol. 2 butanol. 3, 3 dimethyl is a prefix. But is parent chain, root word. Ane is primary suffix. All is secondary suffix. Functional groups is secondary suffix. So 3, 3 dimethyl 2 butanol react with the concentrated sulfuric acid. H2SO4 concentrated sulfuric acid. The concentrated sulfuric acid it gives you proton H plus ions. In the H plus ions because of sulfuric acid means that H plus ions donor. According to in the what? Lowry-Bronsted theory, the sulfuric acid is the strongest acid. The strongest acid completely dissociated, it gives the H plus ions. In the alcohol possess 2 lone pair of electrons. Donate lone pair of electron, accept the proton. So the process known as a protonation of OH group. Protonation of alcohol. To form CH3, then CH3, bond CH, OH2 plus bond CH3. In the positive charge indicate those atoms which have electron deficient species, electron deficient elements. Because of the OH oxygen possesses 2 lone pair of electron. It donate lone pair of electron, accept the proton to form a OH2 plus. OH2 plus. Then removal of water molecule minus H2O. Minus H2O remove. The H2O remove. H2O remove. Oxygen carbon bond break. Both lone pair of electron move towards the oxygen side. Move towards the oxygen side. Gives CH3 bond C, then CH3 bond CH plus, then bond CH3. It is a secondary carbocation. Secondary carbocation. Secondary carbocation. What is meaning of secondary carbocation? The CH plus is a functional group carbon. Functional group carbon. The functional group carbon linked with another how many carbon? 2 carbon. That's why the carbocation is a secondary carbocation. Secondary carbocation. Next, the secondary carbocation followed by methyl shift. CH3 methyl shift takes place. Methyl shift. The methyl group transfer from that carbon to functional group carbon. So to form CH3 bond CH3 bond CH3 the positive charge created on that carbon, CH3, is a functional group carbon. In the functional group carbon, nearest carbon alpha carbon, CH3 and the CH3, both the CH3 are same. Another one, CH carbon also alpha carbon. Functional group nearest carbon alpha carbon, next carbon beta carbon. Here, it is a functional group carbon. Is the nearest carbon alpha carbon. Nearest carbon alpha carbon. Alpha carbon having hydrogen is removed. Hydrogen, that hydrogen is removed means to minus H plus. Removed means to form CH2 double bond C, CH3 single bond CH, CH3 here bond CH3, one way. It is a A type of compounds, one way. Another one way, it is a functional group carbon, nearest carbon CH carbon. That hydrogen removed. That hydrogen removed means to form of another one product. CH3 bond C, and then CH3 double bond C, and then CH3 bond CH3. One products are formed. Then it is a functional carbon. Next carbon, nearest carbon, beta carbon. Beta carbon having hydrogen is removed to form CH3 bond C, and then CH3 bond CH3 CH double bond CH2, CH double bond CH2. That hydrogen removed means to form of CH2 double bond. That hydrogen removed means to form of C double bond C. That hydrogen removed means to form of CH double bond CH2. Totally how many products are formed? 1, 2, 3 products are formed. 3 products are formed. Among the 3 products, that product exists in just 3% of yield. That product exists in just 33% of yield. The product exists in maximum in 33 plus 3 equal to 36. 64% of yield is formed. 64% of yield. The product exists as a 64% of yield. That product exists as a just 33% of yield. That product exists as a just 3% of yield. According to Said-Sief rule. Said-Sief. According to Said-Sief rule, more substituted olefin is a more stable. All reactions are elimination reaction. Here carbon-carbon double bonds are there. Here carbon-carbon double bonds are there. Here carbon-carbon double bonds are there. So the 3 compounds contain carbon-carbon double bond. Unsaturated group to multiple bond. The carbon-carbon double bonds are sp2 hybridized carbon. Okay, sp2 hybridized carbon. That carbon-carbon double bond, that means called olefinic bond, bonded with only one alkyl group, that means called a tertiary butyl group. Only one alkyl group, tertiary butyl group. Another one, that carbon-carbon double bond bonded with 1 and 2. 2 alkyl groups are there. 2 alkyl group. Here, carbon-carbon double bond bonded with 1, 2, 3, 4. 4 alkyl groups are there. More substituted olefin is more stable according to Said-Sief. So, the Said-Sief says more substituted olefin is more stable. Here, 4 substituted group is bonded with carbon-carbon double bond. So, more stable. So, maximum 64% of yield is obtained. Here, 2 substituent groups are there. That's why is a 33% of yield is obtained. Here, only one tertiary butyl substituent groups are there. That's why it exists as a least yield of the product. The process known as a elimination reaction. In elimination process, in the what? In the reaction in which 2 constituents are removed from the molecule. Here carbon-carbon single bond can be changed into carbon-carbon double bond in between the carbon atom attached to already present in a substituents. Elimination reaction always accompanied in change in hybridization. So carbon-carbon in the bond, single bond can be converted to double bond can be converted to triple bond known as a elimination process. In elimination process, new products are eliminated. Another one, oxidation and reduction. Oxidation, reduction. What is the meaning of oxidation reduction? Because of most of the organic reaction is easily oxidized and easily reduced. Most of the organic reactions. For example, ethyl alcohol. Ethyl alcohol oxidized to form of aldehyde. Aldehyde oxidized to form of acid. Acid oxidized to form of carbon dioxide. oxidation and reduction. Oxidation and reduction. Oxidation and reduction. Oxidation and reduction. What is meaning of most of the organic compounds are oxidized and reduced. The oxidation reduction is a common reaction in organic compounds. What is meaning of oxidation? In organic compounds it takes place addition of oxygen known as oxidation. Removal of hydrogen known as oxidation. So addition of oxygen known as oxidation. Removal of hydrogen known as oxidation. This is the oxidation process. What is meaning of a reduction? Removal of oxygen known as a reduction. Then addition of hydrogen known as a reduction. Removal of oxygen or addition of hydrogen known as a reduction process. Addition of oxygen or removal of hydrogen known as a oxidation process. Oxidation as well as reduction simultaneously takes place in a single reaction known as a redox reaction. The reaction is a redox reaction. Here oxidation, here reduction process takes place. What is your oxidation? Addition of oxygen is the loss of hydrogen. Reduction, addition of hydrogen, loss of oxygen known as a reduction process. For example, as ether alga, CH3, CHO, ether alga. Sorry, CH3, CH2, OH, ether alga. Ether alga oxidized in presence of acidified potassium dichromate, K2, Cr2, O7. Acidified potassium dichromate. In the CH2OH group can be converted to CHO, acetaldehyde. CH3, CHO, acetaldehyde. The acetaldehyde CH3CHO can be further oxidized in presence of acidified potassium dichromate K2, Cr2, O7 to form of acetic acid CH3COOH. So, in the alcohol can be converted to aldehyde. Aldehyde further can be converted into then carboxylic acid known as oxidation process. This is a primary alcohol. Next one, secondary alcohol. CH3 bond CH in then CH3OH is the secondary alcohol. Oxidized in presence of oxidizing agent, powerful oxidizing agent of potassium permanganate, acidified potassium permanganate. Secondary alcohol can be converted into ketone. CH3CO on CH3 ketone. Ketone further oxidized in presence of oxidizing agent H plus and KMNO4. In the ketone cannot be easily oxidized. In presence of a powerful oxidizing agent, acidified, alkaline, potassium permanganate or potassium dichromate solution, ketone also oxidized to form of carboxylic acid, CH3COOH, but less number of carbon, one carbon removed as a gas. That compound contains totally how many carbon? 1, 2, 3 carbons are there. 3 carbon. But in the compound contains totally how many carbon? 2 carbons are there. 1 carbon can be lost, 1 carbon removed as a gas. So isopropyl alcohol can be converted to ketone. Ketone can be converted to carboxylic acid, acetic acid. Ether alcohol can be oxidized to form of aldehyde. Aldehyde further oxidized to form of carboxylic acids. It is a simple oxidation process. In aromatic compound, quinol, OH, mon-OH, quinol or 4-hydroxyphenol. 1, 2, 3, 4. 4-hydroxyphenol or 1,4-dihydroxybenzene or paraquinol. Paraquinol. The paraquinol oxidized in presence of acidified potassium dichromate K2, Cr2O7. Potassium dichromate can be converted into quinone, double bond, O. So removal of hydrogen as well as addition of oxygen known as a oxidation process. Alcohol can be converted to aldehyde, aldehyde can be converted to carboxylic acid. Secondary alcohol can be converted to ketone, ketone further can be converted to carboxylic acid. Quinol, paraquinol oxidized by using of acidified potassium dichromate to form of a paraquinone. It is an important one of the oxidation process of organic compounds. Next one, reduction reaction. What is the meaning of reduction reaction? Reverse reaction of oxidation process known as a reverse reaction or reduction reaction. Reverse reaction of oxidation known as a reduction reaction. Here, acetic acid can be converted to acetaldehyde. Acetaldehyde can be converted to ethyl alcohol. Ethyl alcohol can be converted to then hydrocarbon is a reduction. Acetic acid can be converted to then what? Then ketone. Ketone can be converted to then isopropyl alcohol. Isopropyl alcohol further can be converted to then propane is a what process? Reduction process. So reduction. In reduction process. Reduction process. Benzene C6H6 benzene reduced with platinum and hydrogen. Platinum and hydrogen to form of cyclohexane. The compound cyclohexane. So benzene reduced in place of platinum hydrogen to form of cyclohexane. Acetic acid CH3COH reduced in place of lithium aluminum hydride. In presence of or reduced pressure or platinum hydrogen. Acetic acid can be converted to acetaldehyde CH3CHO. Acetaldehyde further react with lithium aluminum hydride or sodium borohydride or platinum hydrogen, palladium hydrogen, nickel hydrogen. The acetaldehyde also can be converted into ethyl CH3CH2OH, ethyl alcohol. Ethyl alcohol react with phosphorus and iodine to form of CH3CH2I or in the CH2I, ethyl iodide. Ethyl iodide further reduced to another one compounds. The process are reduction process. Acetic acid can be converted to acetaldehyde. Acetaldehyde further reduced to form of ethyl alcohol. Ethyl alcohol can be converted to ethyl iodide. It is a reduction. Acid reduced to form of acetaldehyde. Acetaldehyde reduced to form of ethyl alcohol. Is a reduction process. Next one, cyanide. For example, CH3 bond C, double bond N. Methyl cyanide. Methyl cyanide reduced in presence of sodium and ethyl alcohol or lithium aluminum hydride. The C double bond N can be reduced to CH3 bond CH2 bond NH2. It is a reduction process. CH3 CH2 NH2. In the nitrobenzene, C6H5 NO2 reduced in presence of acid medium, tin and concentrated hydrochloric acid. The tin and concentrated hydrochloric acid gives C6 hydrogen atom. NO2 group can be reduced to NH2. NO2 group can be reduced to NH2 plus 2 moles of water molecule. Here, methyl cyanide or acetonitrile can be converted to ethyl amine. Here, nitrobenzene can be reduced to form of aniline by using of acid medium of tin and concentrated hydrochloric acid. It is in the process is a reduction and oxidation process. In oxidation process, addition of oxygen, removal of hydrogen. Ethyl alcohol primary alcohol can be converted to aldehyde. Aldehyde further can be converted to carboxylic acid. Secondary alcohol can be oxidized to form of ketone. Ketone further oxidized to form of carboxylic acid. In the paraquinone can be converted to paraquinone. Next one, reduction process. It is an oxidation reduction. Benzene reduced in presence of in the platinum hydrogen. 6 hydrogen atoms are occurred to form of cyclohexane. Acetic acid reduced to form of aldehyde. Aldehyde reduced to form of alcohol. Alcohol reduced to form of ethyl iodide. Cyanide, acetonitrile can be reduced to form of ethyl amine. Nitrobenzene reduced in tin and HCl to form of aniline. The process known as a reduction process. So oxidation reduction. Oxidation reduction, both processes takes place simultaneously in a single reaction known as a redox reactions. Okay. Next we are going to discuss about functional group interconversion. Functional group interconversion. Functional group interconversion. Because of in the synthesis of organic compounds involve the different functional group interconversion reactions are there. Synthesis of organic compounds involve in the functional group interconversion takes place. Particular functional group can be converted into another functional group by using of different reagents. Depend upon nature of the reagents, one functional group can be converted into another functional group. So next topic is functional group interconversion. Functional group interconversion. Functional group interconversion. Synthesis of organic compounds involved in the interconversion of functional group. Interconversion of functional group. Particular functional group can be converted into another functional group by using of different reagents. For example, CH3, CH2OH. It is an alcohol compound. Oxidized in presence of oxidizing agent. Acidified potassium permanganate to form either CH3 bond CHO. In the CH3 CHO further oxidized in presence of acidified KMNO4 acidified potassium permanganate to form of carboxylic acid CH3 COH. In the acetic acid further react with the ammonia NH3 ammonia to form CH3COONH4 CH3COONH4. In the CH3COONH4 heater set in temperature, the removal of water molecule H2O water removed to form CH3CONH2 CH3CONH2. In the CH3CONH2 further is a react with phosphorus pentoxide P2O5. Phosphorus pentoxide P2O5. Again, removal of water molecule H2O to form CH3C double bond N. Nitrile, cyanide, nitrile, acetonitrile. In the acetonitrile further partially hydrolysis H2O2 and OH minus M. Partially hydrolysis means CH3CONH2 amide. CH3CONH2 amide. In the amide, further react with lithium aluminum hydride. Lithium aluminum hydride to form CH3CH2NH2. CH3CH2NH2. In the amide, react with bromine Br2 and potassium hydroxide. Bromine and potassium hydroxide to form of methylamide CH3NH2 CH3NH2. CH3NH2 further react with chloroform CHCl3 and potassium hydroxide carbon reaction to form then CH3 bond NH bond CH3 is a secondary amine. Secondary amine. In the ethyl amine is a react with nitrous acid HNO2. Nitrous acid means to form of alga. In the secondary amine react with nitrous acid HNO2 means to form of electrophilic substitution reaction CH3 bond N single bond N double bond O bond CH3. What is the functional groups are there? Different functional groups are there. For example, the alcohol functional group. Alcohol functional group. Then alcohol functional group can be oxidized to form of aldehyde. Aldehyde functional group. Aldehyde functional group can be further oxidized to form of carboxylic acid. Carboxylic acid functional group. Carboxylic acid. Next, ammonium salt. Ammonium salt of acetic acid. Then amide functional group. Amide functional group can be changes into cyanide functional group. Cyanide functional group further again converted into ether amide. Amide functional group reduced to form of a primary amine. primary amine. In the acetamide can be converted into methylamine also, primary amine. Primary amine. In the primary amine react with nitrous acid to form of alcohol. Again alcohol form. Primary amine react with chloroform and potassium hydroxide. Ethanol solution of chloroform potassium hydroxide undergo the carbolamine reaction to form of secondary amine. Secondary amine react with nitrous acid to form of N, N dimethyl. N nitroso, N, N dimethyl amine. N nitroso, N nitroso, N, N dimethyl amine. Dimethyl amine. N, nitroso, N, dimethyl amine. So, alcohol functional group can become the aldehyde. Aldehyde functional group can be converted to carboxylic acid. Carboxylic acid functional group can be converted into what? Ammonium salt. Ammonium salt can be converted to amide. Amide further converted to cyanide. Cyanide will convert to amide. Amide in the primary amine. In the amide can be converted to less number of carbon atom of primary amine. Primary amine can be converted into secondary amine. Secondary amine can be converted into N nitroso, N, N dimethyl amine. Yellow oil insoluble in water. That compounds are yellow oil, yellow colored oil, insoluble in water, insoluble in water, insoluble in water. The compounds yellow oil, insoluble in water particles. These reactions all are in the what? Functional group interconversion. Another one, alkyl halide, alkyl halide, ethyl chloride, CH3, CH2, Cl, ethyl chloride. So react with in the alcoholic solution of potassium hydroxide. Ethyl chloride react with the alcoholic solution of potassium hydroxide. Same ethyl chloride react with the aqueous solution of potassium hydroxide. Alcoholic solution means substitution reaction, Alcoholic solution means elimination reaction takes place. Aqueous solution means substitution reaction takes place. K plus and OH minus ions are there. OH minus is the nucleophile. The nucleophile substitute in the place of chlorine in ethyl chloride to form CH3, CH2, OH, ethyl alcohol. The reaction known as nucleophilic substitution reaction. Nucleophilic substitution reaction. Next one, alcoholic potassium hydroxide means elimination reaction takes place. Potassium chlorine removed. OH, then H from the beta carbon. So CH2 double bond CH2. It is a elimination. It is a substitution. Elimination substitution reaction. In this process, all are interconversion takes place. Interconversion takes place. Next one, in the benzyl alcohol. In aromatic compounds, benzyl alcohol CH2OH. Benzyl alcohol. Benzyl alcohol oxidized in presence of acidified sodium dichromate Na2Cr2O7 H plus acidified sodium dichromate. The CH2OH group can be converted into CHO, benzaldehyde, CHO. Further oxidized in presence of a same oxidizing agents. It can be converted into COOH, benzoic acid. Benzyl alcohol can be converted to benzaldehyde. Benzaldehyde can be converted to benzoic acid. Benzoic acid, by treated with calcium oxide CaO, calcium oxide CaO and sodium hydroxide. It is a decarboxylating agent to form benzene. Decarboxylating agent, removal of carbon dioxide, benzene. The benzene further react with concentrated nitric acid HNO3, concentrated sulfuric acid H2SO4, concentrated nitric acid, concentrated sulfuric acid to form of nitrobenzene. Nitrobenzene NO2. Nitrobenzene reduced with tin and HCl to form aniline. NH2, aniline. Aniline further react with nitrous acid HNO2 and hydrochloric acid. Heated at 0 to 5 degrees Celsius. Ice cold condition stable. Try condition unstable to form of benzene disonium chloride. Is an important reagent N2Cl, benzene disonium chloride. The benzene disonium chloride further react with sodium hydroxide. It means called what? Reagent, Comberg reagents. Comberg reagent. Bibenzene is C6H5, this is 6H5. Biphenyl or bibenzene, 5 phenyl groups are formed. Biphenyl. In the N2Cl, benzene disonium chloride is the react with Cu2Cl2 and hydrochloric acid. It means called what? Sandmeyer reaction means to form of chlorobenzene. Chlorobenzene Cl. In the chlorobenzene further react with sodium hydroxide NaOH. Heated 623 Kelvin. 300 atmospheric pressure. 300 atmospheric pressure. The nucleophilic aromatic substitution reaction takes place to form of phenol. Phenol. In the phenol again react with different reagents. Different reagents. Nitrate mixture means ortho, para, nitro, phenol. Ortho nitrophenol, para nitrophenol, picric acid. 2,4,6 trinitrophenol also picric acid. Nitrous acid means para nitrosophenols are formed. Sulfuric acid means para hydroxy benzene sulfonic acids are formed. Chlorine in process of Lewis acid means to form of orthochlorophenol, para-chlorophenol. It reacts with bromine water or 2,4,6 tribromophenol is a characteristic test for phenol form. The compound react with phthalic anhydride in presence of sodium hydroxide to form of a phenolphthalein indicator. Phenolphthalein indicator is also formed. The phenol can be converted to paraquinone by treated with chromyl chloride. Chromyl chloride. The phenol can be converted to cyclohexanol by treated with nickel and hydrogen. So different interfunctional group conversion takes place when depend upon attacking reagents, depend upon nature of the reagents. Here CH2OH aldehyde functional group can be converted into aldehyde. Aldehyde functional group can be converted into carboxylic acid. Carboxylic acid functional group can be converted into hydrocarbon. Hydrocarbon can be converted into nitrobenzene, NO2 group functional group. NO2 can be converted to amine functional group. Amine functional group can be converted into N2Cl, disonium salt. The disonium salt can be converted into haloarine. Haloarine can be converted to alcohol. So different functional group interconversion takes place. It's depend upon attacking reagents. Okay students, today topic over. Next topic we will meet the next video. Thank you.